Now, converse of basic proportionality theorem. Converse of basic proportionality theorem. Converse of basic proportionality theorem. Very simple. We learn the theorem that if in a triangle a line which is parallel to a side of a triangle which intersects the two lines in two different points, then that line divides the two segments in same proportion, which the basic proportionality theorem we already learned. Now, converse of basic proportionality theorem. If a line which is intersects the two lines in two distinct points and divides them in the same proportion, then that line is parallel to line BC. Means we have to show line L is a parallel side BC. The proof of this theorem is not given for you, but the examples are asked in your examination on converse of basic proportionality theorem. Which type of examples are asked? For example, this is a triangle. Here the measures of the segments are given 6, 12, 18 and x or 36. So we have to ask that can line L is parallel to BC? We have to ask, or we have to show line L parallel side BC. So here we have know the sides. So AP upon PB is equal to 6 by 12 is equal to 1/2. AQ by QC is equal to 18 by 36 is equal to 1/2. Let's find first and second. From 1 and 2 we can write AP upon PB is equal to AQ upon QC. So by converse of BPT, we can show, or we can say L is parallel to BC, because that line L divides the two lines in the same proportion, and so we say that line L is parallel to side BC. So by converse of BPT, line L is parallel to side BC. In your book, some examples are given. If you open your book, then on page number 13, page 13, a question is asked that a figure is given. PRQ and N. Now in triangle PQR, PM is 15, PM is 50, PQ is 25, PQ is 25, PR is 20, and we have to ask NR is 8. So if PQ is 25 and PM is 50, then obviously QM is 10. If PR is 20, NR is 8, then PM is 12. So we have to ask that state whether line NM is parallel to side RQ. NM is parallel to side RQ. So here if you take the ratio as PN divided by NR is equal to 12 by 8 which is 3 by 2. Now PM by MQ is equal to 15 by 10 which is equal to 3 by 2. From 1 and 2, the right hand side of equation 1 and 2 is equal, and so we can write Pn upon NR is equal to PM upon MQ. And so by converse of BPT, side NM is parallel to side PQ. In this way, such type of examples asked in your examination. Now, today we had learned about basic proportionality theorem and its examples. Also, the converse of basic proportionality theorem and their examples.